This really isn't a bad way to do these videos. I've actually done this one just a couple of days ago, and so I can play it and then I can go back and make additional comments and maybe correct some of the things that I said that I didn't really like the way that I said them, or maybe they weren't as clear. And so I'll play it and then I'll interrupt as needed to go through and to make it better. Probably be at least 2 of these sessions. This first one is already 10 minutes long, and I'm sure that I'll make some comments as we go along. But let me go ahead and get started with this material. And but before I do that, let me just go back through one more time and help you to understand that what we're doing is we're building for the future. If we go through and look at chapter 2, we talked about descriptive statistics. And in chapter 1, of course, we talked about data and how we get that data. Chapter 3, we talked about what we can do with some of the sample statistics. Find into things like the measures of central tendency and variability. In chapter 4, we introduced the probability concepts. And so now we're going to take parts of all of these and we're going to use those to build up, in this chapter, discrete distributions. Of course, if we have discrete distributions, and you know that there are continuous distributions, and then that's going to be the topic of chapter 6. So, believe it or not, we are actually building these things up so that they will end up in to make some sort of sense eventually. But discrete distributions will be those distributions that have counting numbers a lot of times as the values. 1, 2, 3, 4, 5. Continuous distributions will have numbers like 1.1, 1.2, and there is a considerable difference between those two. The two primary discrete distributions that we'll be looking at are the binomial and the Poisson. So let me go ahead and start this video that I made the other day, and let's just see how it works. And then as I feel the need to make comments, I'll interrupt. So let's get started. But chapter 5 is probability distribution. It goes through and talks a little bit about random variables and probabilities. And remember that the important thing about a probability distribution is that the area under the curve, that is the sum of the probabilities, is equal to 1. And so if you have a situation where the sum of the probabilities is different than 1, it's not exactly 1, then it can't be a probability distribution. So let's look at some information here, how it works out. So we're going to flip a pair of dice here, and so when we flip these die, there are 11 outcomes that can occur. We can roll ones, 2 ones, and get the sum of 2, or we can roll 2 sixes and get a sum of 12. Those are the extremes. That's the largest value and the smallest value that's possible. So if you add those up, there are 11 possibilities. there's one way to roll a 2. So if you go and think about this, you can create a little chart. And this would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. A 1, 1 would be right here. A 6, 6 would be right here. And so you can see that there's only one way to get a 12. There's only one way to get a 2. So those occur 1/36 of the time, each of those. To get a sum of 3, you can roll a 1, 2 or a 2, 1. So there's 2 ways to do that. To get a 3, or to get a sum of a 4, you can roll a 1, 3, a 2, 2, or a 3, 1. So you have those values. It just goes all the way through. You can see at the maximum value, the maximum probability is to roll a 7, a 6, 1, a 5, 2, 4, 3, 3, 4, 2, 5, 1, 6. There's 6 ways that you can do that. So if you were to graph this out, you'd actually see that this is going to look sort of like a stair-stepped triangle. Okay? So it's going to have a triangular shaped. I warned you several times that I'm not an artist, but hopefully you get the idea where this one right here is going to be the 7, and there's going to be 6 ways that can occur. So you have 6/36. So that's a probability distribution. If you add up all of these, you're going to come up with all these values, 1, 2, 3, 4, 5, 6, all the way down. That will come up with 36. So if you sum these all up, you'll get 36/36. And you can see that fairly easily because the 5 and this 1, 4, and this 2, 3, and 2, 2 and 1. So you've got 1, 2, 3, 4, 5, 6. 6 times 6 is going to be your 36 if you want to look at it that way. Okay. Okay, so let me interrupt at this point and just go back and re-emphasize the point that we just made on that, because it's very important. It has to do with the definition of what we're going to call a probability distribution. Okay, and the definition of a probability distribution is that every probability is greater than or equal to 0, and also less than or equal to 1. You can see that on that rolling the dice, that the probabilities ranged from 1/36 to 7/36, back down to 1/36 for 2 all the way up to the 12. The other important characteristic of a probability distribution is that the sum, and we use this symbol to represent sum of the probabilities of x are equal to 1. So all those probabilities, all the different outcomes that we could get, those probabilities all sum up to 1. Okay, I'm going to end this video at this point right now, and we'll come back and continue on with this in just a minute. So We'll check with you later.